share this to you. Cool. All right. Do you see a page on the screen? Yeah, great. Cool. I think the question is, how do you know when to do that times 10 to the whatever thing? And your keywords are the units. So the keyword for that create the huge number, right? The 6.022 times 10 to the 23rd. When do you use that number? Use this number when your units are atoms or particles or molecules or oh, this is really blurry. There. Okay. Yeah, so use that big number when you're looking at the units of the small stuff. You know, so if it's asking about how many tiny things, how many atoms or molecules or whatever, that's when you use that big number. And it's that many things in 1 mole. So if you start with some number of moles, you know, you started with some amount of moles, and you want to know how many particles, something like that. That's kind of your start and your end. So your question will say, how many particles do you have if you have 3.4 moles or something like that? And do all the units all the way across first. So we figure out like what goes here. And we're solving for particles, so we want that particle word on top. And we're starting with moles, and we want to get rid of moles, so that unit is going to go from the top where it started down to the bottom of the next thing. It's all one big fraction. Same thing on top and the bottom cancels out. And then here is where we use the really big number. If we're solving for particles, particles are super tiny. And solve for particles, 1 mole is always that many particles. I can't actually hear anybody. I don't know if you all have yourselves on mute. How does that look so far?
That looks good. Makes sense.
Cool. And then your last step there is to kind of your math step, multiply all the things on the top, and then there's kind of two ways you can do this math step. So you always multiply across the top, and then you can divide across the bottom, so divided by 1, or you can multiply across the bottom and then divide bottom, and then in your last step divide top divided by bottom. I left my calculator in a different room, but I can use it internet. Or if somebody has a number, we can throw out a number. This would be about 21, I think. Alright, so 20, I'm just gonna write down this whole thing. Okay, so that's kind of your calculator number. You took these two base numbers and multiplied them together. Get that as your base number. And there's that times 10 to the 23. The times 10 to the 23 just kind of came along with. We didn't calculator it. It's 23 place values, that's huge. We just kind of take it with for the ride. Times 10 to the 23 started on top. Times 10 to the 23 will end on top. And that right there is a correct answer. That's just fine. If you're going for your finishing touches, you're gonna look at your sig figs, figure out how many of those decimals you care about. We started with 2 sig figs, we'll end with 2 sig figs. And your final step, you want your decimal after your first digit. So we moved it 1 time. To make your base number big to small, so move your scientific notation 1 time to make your exponent small to big. That is a correct answer too. Does that make some sense of the times 10 to the 23 thing?
Okay.
Would you like another one like this? Or another one with different units, or...
That makes sense to me. I just had a quick question on the homework that we're turning in today.
Go for it. Yeah.
With the molar ratios in number 4 and number 5, when it gives you stuff like 4NH3 to 2NH2, technically the ratio that you put in the video, it's 4/2, which makes sense to me because that's what it's asking for. Are we not supposed to reduce it to 2:1? Do you want us to leave it with the original values?
It's a great question. In terms of math, you could do either. You can
Yeah.
reduce a ratio. That's totally fine. And yes, I mean you can. There's no reason you can't. I tend to leave them with the actual coefficients because
Yeah,
every once in
that
a
makes sense.
while you miss something up, or you switch something, or like you pull the wrong number, or like you're aiming for
Okay.
this number but you pull that one. It kind of makes your work like easy to check, when you're going backwards on it and you're like, did I even pull the right numbers? Like, I wanted moles of O2, did I pull something else? Moles of O2, it's kind of easier to check when it's the same actual numbers, but
Yeah,
they're
that
both
makes
right.
sense. I was just okay. So I'll just make sure I do that, but on my corrections for it, I just put the actual value underneath it, just showing that I know what you're talking about. And then in my sentence thing, I just said that I wouldn't do that. I was just wondering because I looked at it with math in my head and then I reduced everything, but it makes sense. But yeah, that's all. That's the only question. I didn't mean to transition from the other thing we were talking about, but thank you.
Yeah, no problem. Glad you asked. Cool. Yeah. What other questions do we have? We can go anywhere at all. We can... Would you like more conversion examples?
We do one converting to grams.
I like it. Would you like to make up the question? Cool. So we're going to convert to grams. And even already, since we know we're converting to grams, you can write equal sign grams. Like, starting at the end is a great place to start, because now you know where you're going. There's so there. Part of what's like interesting about this unit is that you develop the flexibility that you can get to grams by way of all sorts of other stuff. So we could get to grams from moles. We could get to grams from atoms. We could get to grams from liters. We could do all of those things. If you start or end with moles, it's 2 steps. So if you start or end with moles, it's 2 steps. So, and what the, oh gosh. There. Okay. I should have written that differently. It's a 2-step conversion. But if you start and end with things that are not moles, then you're looking at more like 3 or 4. There. If so, if you start and end with not moles, then it's like more steps. In this one, would you like, or I'll give you something, sorry. Would you like to start with moles, or would you like to start with something else?
Something else.
Something else. I like it. Let's do, how about atoms? Alright. I like it. Yeah, we're gonna start with something else. Here's another way to think about it. If you start and end with not moles, it's always more steps. And moles are always in the middle. There's always a mole in the middle. Okay, let's do it. We're gonna start with something else. We're gonna end in grams, and we've got moles in the middle. Let's actually start where we know. So we know that we're ending in grams. And we know that we're starting with, let's do atoms. So we're starting and ending with not moles. There's moles hidden in there, and they're always in the middle. So your starting thing always starts over 1. And then do that canceling out thing. What's the unit on the bottom over here? Agree. Yeah, that's atoms. Yeah. And you knew because atoms started on the top, and we want to get rid of them, so we're going to kick them down to the bottom. And do it again. What's your unit down here? Kids here. Sorry, somebody mouthed the answer last time. So you're going to start with atoms, cancel out atoms. You've got moles. You're going to cancel out your moles also. And you're left with grams on top. Grams is what you're solving for. How's that looking so far? That right there is sometimes the hardest step. Like getting the units to cancel. For your next step, we're going to look at each of these little blocks kind of individually. So we'll look at that one by itself, and that one by itself, and that one by itself. Okay. So for here, I'm not even going to give you a number yet over here, because I don't want to make you think about it more abstractly. As soon as we put a number here, then people start punching their calculators. We're going to put the numbers here and here first. Let's do this one first. How many atoms are there in a mole? I saw one person say it.
6.022 times 10 to the 23rd.
There you go. Yup. Every single time. Anytime you've got the word atoms, the number that goes with that word is that big number. You're asking, like, when do we use that times 10 to the 23, whatever? Anytime you've got atoms, particles, molecules, the number that goes with that word is the 6.022 times 10 to the 23 number. goes with atoms, molecules, particles. It's that many in 1 mole. And that's done. We've got the numbers on both sides of that conversion factor. In our next one, yeah, our question here was like, let's solve for grams. Anytime you're looking at grams, you need to know what it is, like what substance it is, because different things weigh different amounts. So if this was some, let's say this was some crazy big thing, right? A heavy metal with a whole bunch of polyatomics, that's gonna weigh a lot. But if it's something smaller, something like that, that's gonna weigh less. This will weigh even less. Kind of the mass, the grams, has to do with what the thing's actually made of. Or I could do, some of your really big heavy metals, just they weigh a lot, they're heavy. The 1 mole of something heavy weighs more than 1 mole of something really light. So let's do H2. Why not? Could be any of these things. Or would you like it, so if it's something like H2, you're going to take the mass of 1 hydrogen, multiply it by 2, that's your mass. If it's something like lead-3 nitrate or something crazy like that, now you've got to solve for the molar mass of this thing. So in your review guide, I gave you soap, which has a huge molar mass because it's like 18 carbons or something like that. And you can do that too. I don't know if I remember the formula of soap offhand. We could do candle wax. Like whatever it is, which is C50, H101. So like a mole of candle wax weighs a lot more than a mole of like gas. Anyways, let's stick to a single thing. So if you have a heavier thing, you get to solve for that mass, and that mass will still follow the grams. Does that make some sense? Cool. Okay, let's forget all of this for now. Let's say we're working with H2. And we've got grams, so we need a mass. So grams, if you have the unit of grams, you need a mass. Let's say here we've got H2. Inside of H2 we have 2 H atoms. Each one is 1.01 grams. So your total molar mass. And we'll pull it back up too. It's got more space there. So we had grams to moles, like comparing grams to moles. So what we did, since we had grams, we solved the molar mass. 2 H atoms, they each are 1.01 grams. Altogether, it's 2.02 grams. for your last step, there's your grams, there's your moles. Which side does that 2.02 number go on? In your fraction here, does that 2.02 go on the top or the bottom? And it, yeah. Does the 2.02, does that go with the grams or the moles?
Grams?
And how do you know?
Well, because it's saying how many grams there are per mole, not how many moles there are per grams. That's how I thought of it.
Yeah. Yeah, I like it. Yeah, it's that many grams per mole. And are your grams, in this one, are your grams on the top or on the bottom? Do you see that? Cool. Yep, and it follows that word. So your grams are on the top. And that 2.02 has a unit of grams. So it's going to follow the grams. The grams here are on top. So the number follows the grams to the top. We've got moles on the bottom. It's that many grams in every 1 mole. It'll always be just 1. Alright. To solve this out, let's give you a number up here. I'm going to make you do a little bit of scientific notation to get some practice with that also. And in your final step, so there's kind of 3 steps. There's the units and the numbers and then the math. So we got our units, we got our numbers, here's our math. Multiply all the things on the top, so 4 times 2.02, and let's just do that right there, divided by the stuff on the bottom, and we'll take that scientific notation along also. So your top has a times 10 to the 25, your bottom has a times 10 to the 23, and calculator that a little bit if we can. So you're just doing 8.08 divided by 6.022. I'll give you 1 point something. 8.08 divided by 6.022. And I'm going to move this over to make a little bit more room. So 1.34, let's give you another sig fig. So 1.3 times 10, okay. Here's a little bit more scientific notation. We've got times 10 to the 25 on top, times 10 to the 23 on the bottom. You're dividing, so subtract those exponents. If you want, you can think of it as writing out 25 times 10s on top and 23 times 10s on the bottom, and write the whole thing out. 23 of them will cancel top to bottom, and left on top there's going to be 2 times 10s left on top. And there's your answer. What do you think? Great. I'm so glad you asked. And I'm glad you wanted the trickier version too. The starting with something else version. Yeah. Would you like another? And if so, what kind?
I think we're good. Or I'm good at least.
I'm
I
glad you
feel
asked.
good too.
I
I
feel
agree with that.
I feel pretty good. I was just wondering, like on the quiz and stuff like that, do you want us to necessarily use sig figs too?
Great question.
Good question.
Yeah, do you have to do sig figs? If you're doing sig figs, awesome. If you're not doing sig figs, that's just fine too.
Okay.
You don't ever have to.
Okay. I was just making sure. That's all I have for a question.
Cool. Did you have a question, Dana?
Nope.
I can't see your hand signals as much. Oh, there you go. All right, using tech to... Yeah, I like it. Great. Cool. Is there someone else here? I can only see a couple people when I screen share. Okay. Oh, Anya, I couldn't see you the whole time. Hi.
Hi, I'm good. I was just watching and observing.
Awesome.
It makes sense. So, yeah.
Awesome. Good, good. What other questions would you like? We could do a complicated molar mass. We could do another long conversion thing.
Are we allowed to leave the Zoom if we feel ready?
Yes. Yep.
Okay.
Yep.
Then
if
I'm
you're
a bounce.
Cool. Nice to see you.
Goodbye.
Have a lovely weekend.
Yeah, thanks.
See you soon.
I feel ready too, so I'm gonna head out and do the quiz.
Cool. Good luck. You got it.
Thank you.
Thank you. Take care.
Yeah, me too. Thank you so much.
You are so welcome.
Bye.
Bye. Have a good weekend.